Good morning. So 4 pictures are displayed behind me, and while they seem quite diverse, a common feature binds them together. Can you guess what it is? Okay, disasters. Maybe. What else? Lack of maintenance. Okay. Anything else?
Design failure?
Okay. Not exactly. What we're seeing in those 4 pictures are different types of developments. We see the Dubai skyline. We have a Lebanese facade that needs maintenance, a highway that was struck by an earthquake, and the London tower that was on fire recently. These different developments are different impacts on the environment, and the impact of concern for me is that they have all generated and will generate construction and demolition waste. My name is Nadine Zagrini, and my topic for this presentation is how to manage, using queries, the recycling of this waste. So first we have to understand how is construction and demolition waste managed globally. And a solution for this debris was to restore abandoned quarries and build in them recycling facilities and landfills. However, is this an environmentally friendly solution, and is it an economically viable one? And also, what methods can I use to optimize the efficiency of the solution proposed? These are the questions I'll be answering in this presentation. So, as we all know by now, the construction sector is one of the most active and major sectors in every country. Construction activities are twofold. They boost the economy on one hand, however, they damage the environment as well. In reality, one apartment requires 200 to 300 tons of aggregates, while 1 kilometer of road requires 5,000 tons versus 20,000 tons for 1 kilometer of highway, and that's according to the Ministry of Environment in Lebanon and the United Nations Development Program in 2011. We have different sources of waste. Some are generated by emergency states, such as natural or man-made disasters. Others can be generated by non-emergency states, such as regular construction, demolition, and maintenance of buildings and infrastructure. My work will be focusing on the waste generated by non-emergency states for buildings only. As such, the composition will vary depending on the stage of the project. During excavation, we might find some soil or rocks. During construction or demolition, we might have concrete, tiles, masonry, or steel. And during the finishing phase, we'll find some wood, plastic, metals, and even some hazardous materials. In short, the management of this waste is a challenge. And proper management will require quantification of the debris being generated, as it provides vital inputs to the locations and the capacities of the facilities that are needed to be built. Different methods have been adopted in the literature depending on the availability of statistical data. Here I'm presenting 2 results from 2 studies. The first presents the waste generation rate in percent per type of waste. As we can see, masonry, concrete, and tiles amount to almost 75% of the waste and will be the focus of my study. The second one shows the results in kilogram per meter squared of built-up area for construction and demolition of residential and non-residential buildings. As you can see, the waste rate can reach up to 850 kilogram per meter squared, which is huge. Now, the reuse rate have reached up to 80% in some of the countries, such as in Germany, Denmark, Netherlands, and that's according to the Eurostat in 2015. However, in other countries, such as my country, Lebanon, recycling initiatives are rare to non-existent, and this can be attributed to the following barriers. Construction projects have long lifespans, entailing different owners with different attitudes towards recycling. We have absence of deconstruction design according to the specific accounting for the specific risks of every project. We don't have proper monitoring. We lack the legal and economic incentives, and we don't have the adequate processing facilities with sufficient capacities. Now, moving on to solution, if we're wondering what we do with waste, the first thing that pops into our mind is recycling. However, is it really an environmentally friendly option, because if we think about it, using recycled aggregates will lead to the use of aggregates with smaller sizes, implying a larger surface area, which will require more water and more cement. Studies have showed that 30% less damage is caused on global warming only if the facilities are adequately located. Now, how do we locate these? In order to do that, we need to understand the construction and management chain. So this is it. We have to start by extracting the aggregates from the quarries. These will then be used in concrete or as raw materials in the construction. And this by itself will generate some waste. This waste will have to be sorted. Some will be landfilled, others will be recycled. After a period of time, the construction developments will have to be demolished or maintained, which will also generate more waste to be sorted, either landfilled or recycled, as suitable. So the status quo right now, we have the different centroids generating the waste and presented as circles. We have the abandoned quarries presented as rectangles, and we also have the markets. And the solution I'm aiming for should help us choose which quarries are suitable to build in them the recycling facilities, and these are colored in green, which one should be used to build landfills, and these are in brown, and the mass flows between them. Different methods, different decision-making tools have been used to evaluate the adequate locations. I will be citing two main ones, which are GIS, Geographic Information System, and mathematical programming. So GIS, with the method named rates of evidence, have tried to find patterns in the maps of existing locations and project them on future ones. A second method is the multiple criterion evaluation. So we have different criterions that needs to be satisfied in the places chosen. For example, we're going to take the slopes. The lands with slope less than 10% are suitable for me. I will assign for them a higher score than the lands with higher slopes, etc. And then I will sum up all the layers, and the one with the highest score will be suitable for me. And the second method is mathematical programming. And in my work, I'll be combining both. I will be using GIS to choose from all the abandoned quarries the ones that are adequate to build in them recycling facilities and that will not cause severe damage on the environment. And then through mathematical modeling, from these queries, I will be choosing which one should be transformed into recycling facilities and which will be transformed into landfills. Now, when we talk about mathematical modeling, we think of an objective function. And the first thing that occurs to our mind is minimizing the total costs. However, this will not be my objective in this model. I will aim for maximizing profits for the facility operators, since these will be the base behind the green initiatives in countries that lack legal incentives. As for the variables, these will be the quantities of the different types of waste transported and the capacities as well as the locations of the different types of facilities. The constraints I need to abide by are the mass balance for the system at each node or facility, the capacity limitations, the market demand, and the area limitations. The model parameters used as inputs can be divided into three categories. I'm going to be needing the composition of the waste, which are cementitious, which are non-cementitious, and which can be recycled into coarse versus fine aggregates. I'm going to need to know the location of the abandoned quarries and the respective areas. And finally, I need to have some idea about the prices, the cost that it takes to landfill, to recycle, the revenues, the gate fees, etc. Now, my model presents several advantages. It accounts first for the complete construction and demolition waste management chain, which is rarely addressed in the literature. It also provides an environmental and an economical solution for the waste management, especially in countries that lack economic and legal incentives. As for the limitations, I have faced several ones due to the lack of statistical data, and I have made some assumptions in order to simplify the model. For example, I had to assume uniform facility layout, which implies discrete capacities. My model was limited to cementitious debris from construction and demolition of buildings only, and some assumptions were made on the location of the centroids and on the demand. And this is mainly due to the lack of data available. Currently, I'm working on formulating and validating my model according to the variables and the constraints already defined. In parallel, I'm working on the GIS model, which will help me select the abandoned queries that satisfy the multiple environmental criteria specified by regulations. And finally, my work will be applied on a case study on Lebanon, currently experiencing a trash crisis. Thank you.